Scientists launch a futuristic time machine or fusion reactor to generate endless energy. Combination reactor alludes to a type of thermal power produced when lightweight particles melt. It is a Krebs cycle at work in each star center, there overwhelmingly of energy. Scientists have been attempting to bridle combination and imitate it on Earth in a controlled way. In the event that they succeed, they will give the world a protected, reasonable, naturally dependable and plentiful wellspring of energy. For a really long time, established researchers have been chasing after atomic combination, but at this point, research has arrived at a basic stage as researchers are building an exploratory reactor that one day might show the way that combination can be utilized economically to make electrical power. For more than 50 years, energy has been generated in nuclear power plants through fission, a process in which heavy elements such as uranium are bombarded by neutrons, releasing heat in the process. In fusion reactors, light atomic nuclei are compressed under intense pressure and heat to form heavier ones and release energy in the process. The process must be optimized to generate more energy than it consumes. With a sufficiently large and sustainable energy profits, fusion could be utilized to generate electricity commercially. The main fuels used in nuclear fusion are deuterium and tritium, both heavy isotopes of hydrogen. Tritium can be made from lithium, which is also abundant in nature. The amount of deuterium present in 1 liter of water can, in theory, produce as much energy as the combustion of 300 liters of oil. This means that there is enough deuterium in the oceans to meet human energy needs for millions of years. Building a fusion power plant that can withstand the immense temperature and pressures this process produces is one of the century's greatest engineering challenges. The fuel made up of the hydrogen isotopes, deuterium and tritium must be heated to about 100 million degrees centigrade. At that hotter than the sun temperature, a fully ionized gas plasma is formed. The plasma will then be ignited to create fusion. At present, scientists are pursuing 2 methods for achieving nuclear fusion: inertial and magnetic confinement. In inertial confinement systems, ion beams or laser beams are used to compress a pea-sized deuterium tritium fuel pellet to extremely high densities. When a critical point is reached, the pellet is ignited through shock wave heating. Fusion power plants using this technique would ignite fuel pellets several times per second. The resulting heat is then used to generate steam that powers electricity generating turbines. In magnetic confinement systems, electromagnets are used to contain the plasma fuel. One of the most promising options, the tokamak device, contains the plasma in a donut-shaped chamber. A powerful electric current is induced in the plasma, resulting in an increase in temperature. The plasma is also heated by auxiliary systems such as microwaves, radio waves, or accelerated particles. In the process, temperatures of several hundred million degrees centigrade are achieved. The potential advantages of nuclear fusion energy are manifold, as it represents a long-term sustainable economic and safe energy source for electricity generation. Fuel is inexpensive and abundant in nature, while the amount of long-lived radioactive waste and greenhouse gases produced through fusion are minimal. While research on nuclear fusion continues, Many spin-offs relating to plasma physics and fusion technology are already benefiting society. Users of mechanized plasma cutting for plates in the gauge to 1 in-thick range can now benefit from a major technological breakthrough. Improved plasma bolt hole cutting can now produce holes that rival drilled holes and plate laser cut holes at the speed and operating cost of plasma. Manufacturers of plasma cutting systems relentlessly pushed the laws of physics to extract the best performance. They reduced cut costs by increasing the life of the touch consumable parts and improving the cut edge angularity and minimizing dross formation. This created more applications for this high-speed metal cutting process. Over time, other major improvements in plasma cutting followed: oxygen plasma cutting, long-life consumable technology, and the high-definition plasma cutting technology. The platform that the plasma touch depends on, the CNC cutting machine which controls touch motion, also benefited from many technological innovations we won't be mentioning today. Also, the laser cutting acrylic is an exceptionally popular application for Epilog laser machines because of the high quality results that are produced. Depending on the type of acrylic you are working with, the laser can produce a smooth, flame polished edge when laser cuts, and it can also produce a bright, frosty white engraving when laser engraved. Before beginning to experiment with acrylic in your laser, it is important to understand the different types of these substrates. There are actually two types of acrylics suitable for use with the laser: the cast and the extruded. Cast acrylic sheets are made from a liquid acrylic that is poured into molds that can be set into various shapes and sizes. This is the type of acrylic used for most of the awards you see on the market. Cast acrylic is ideal for engraving because it turns a frosty white color when engraved. Cast acrylic can be cut with a laser, but it will not result in flame polished edges. This acrylic material is better suited for engraving. The other type of acrylic is known as extruded acrylic, which is a very popular cutting material. Extruded acrylic is formed through a higher volume manufacturing technique, so it is typically less expensive than cast, and it reacts very differently with the laser beam. Extruded acrylic will cut cleanly and smoothly and will have a flame polished edge when laser cuts. But when it is engraved, instead of a frosted look, you will have a clear engraving. To achieve the best result when cutting extruded acrylic, you will want to elevate the material so that it's not touching the cutting table. This will greatly reduce backside reflection and the occurrence of grid marks on the material after being laser cut. Epilog spin table is the perfect accessory to help you get those perfect cuts on extruded acrylic. This handy device allows you to raise and support your acrylic for better cutting edge quality. The pin table incorporates movable pins that can be placed anywhere along the table's grid of 1 inch, about 25.4mm spaced holes. The acrylic is raised and supported in locations where the laser will not be cutting, which is what helps eliminate backside reflection. The pin table also allows you to place pins to support small or intricate parts that would normally fall out of the cutting pattern. A 30 or 40 watt Epilog system will cut through up to 1/4 inch of acrylic. As you increase in wattage, you will be able to increase the thickness you can work with. A 50 or 60 watt machine will allow you to cut through closer to 3/8 inch of acrylic, and a 75 or 120 watt system will allow you to cut closer to 1 to 2 inch or possibly 3 to 4 inch with 2 passes. Cutting acrylic is actually best achieved with relatively slow speed and high power. This cutting process allows the laser beam to melt the edges of acrylic and essentially produce a flame polished edge. Today, there are several acrylic manufacturers who produce a variety of both cast and extruded acrylics that feature different colors, textures, and patterns. With so much variety, it's no wonder acrylic is a very popular material to laser cut and engrave. For the most part, laser users engrave acrylic on the back side to produce a look-through effect from the front. You will see this often on acrylic awards. Acrylic sheets typically come with a protective adhesive film on the front and back to prevent it from getting scratched. We recommend removing the protective adhesive paper from the back of the acrylic before engraving, and leaving the protective cover layer on the front to prevent scratching while handling the material. Don't forget to reverse or mirror your artwork before sending the job to the laser, since you will be engraving the back side. Acrylics generally engrave well at a high speed and low power. It doesn't take much laser power to mark the acrylic, and if your power is too high, you will notice some distortion in the material. You can acquire cast and extruded acrylic from a number of material suppliers in your own locality using your Google GPS. General laser processing tips for acrylic. 1. Never leave your machine unattended when working with acrylic. Many materials are susceptible to igniting, but acrylic, in all its different forms, has been shown to be especially flammable when cut with the laser. As a general rule, you should never run your laser using any material if you are not present. 2. Make sure to choose the right type of acrylic for your application. Remember, cast acrylic is better for engraving, while extruded acrylic is better suited for laser cutting. 3. Elevate the acrylic using epilogue spin. 4. Use stable or other supports to eliminate backside reflection. Acrylic is a durable and practical material for laser processing. The variety of colors and textures make this material ideal for all kinds of things. The laser machines could also be used for other mechanical works like cutting of wood or mirror through a CNC mechanism. Please send more information about using a laser machine for cutting acrylic, steel, wood, even the glass. The metallurgical plants use coal, coke, oil, gas, and power, for the most part coal-based, to address their issues for energy. The extent of type of energy used relies upon its accessibility in the specific region. While finding a metallurgical plant, many variables must be thought of. For example, accessibility of unrefined substances, power, work, and so on, notwithstanding financial matters and unofficial laws. Taking into account two different issues, energy effectiveness and natural pollution, is turning out to be progressively significant. This part depends on the involvement with India to upgrade energy efficiency. Metallurgy used to be an art rather than science until mid of 19th century, during which period large metallurgical plants were developed based on empirical relations, trial and error, intuition, etc., and operated successfully. Since more than 1.5 centuries, metallurgy has emerged as a science and more predictive. Therefore, in metallurgy field, often the problems are posed in terms of real problems which plants are facing during operation, like less productivity, environmental problems, etc., which involves production of alloys, shaping, heat treatment and surface treatment of product. The task of the metallurgist is to achieve balance between material properties such as cost, weight, strength, toughness, hardness, corrosion, fatigue resistance, and performance in temperature extremes. To achieve this goal, the operating environment must be carefully considered. Determining the hardness of the metal using the Rockwell, Vickers, and Brinell hardness scales is a commonly used practice that helps better understand the metal's elasticity and plasticity for different applications and production processes. Here is how a molten metal is poured into a shaped mold. Variants of casting include sand casting, investment casting, also called the lost wax process, die casting, and continuous castings. Each of these forms has advantages for certain metals and applications, considering factors like magnetism and corrosion. And here also a red hot billet steel hammered and shaped into desired conformity in the forge house. Metals can be heat treated to alter the properties of strength, ductility, toughness, hardness, and resistance to corrosion. Common heat treatment processes include annealing, precipitation, strengthening, quenching, and tempering. Reconnaissance is a technique for checking of conduct, numerous exercises, or data with the end goal of data gathering, impacting, overseeing, or directing. This can incorporate perception from a good ways through electronic gear like short circuit TV, also known as CCTV, or interference of electronically communicated data like internet traffic. It can likewise incorporate straightforward specialized techniques, for example, human knowledge gathering and postal block attempts. Surveillance 3D security cameras are used by citizens for protecting their neighborhoods and by governments for intelligence gathering, including espionage, prevention of crime, the protection of a process, person, group, or object, or the investigation of crime. It is also used by criminal organizations to plan and commit crimes, and by businesses to gather intelligence on criminals, their competitors, suppliers, or customers. Religious organizations charged with detecting heresy and heterodoxy may also carry out surveillance deployment. Whether you want to keep an eye on employees at nearby facilities or documents every person approaching your home's front door, the right equipment for the job is your 3D surveillance security cams. One of the first decisions that you will need to make is if you need a wireless or wired security camera system. And the correct answer likely depends on where you intend to place the cameras and components. If you have the luxury of being able to drill holes and run wires, you will appreciate not having to deal with batteries and may want to look at a wired system. On the other hand, if running wires isn't realistic, you will enjoy the versatility that Wi-Fi and wireless cameras such as these collections offer. All these considerations will affect what system you ultimately choose. Cars ultimately run on gasoline and people run on tea and coffee. Oh yes, at least in my house. If you drink coffee or tea by the bucket, you will be glad someone once had the gumption to invent a super efficient way of turning cold water into hot, namely the electric kettle, also known as electric tea kettle. Fill it with water, plug it in, switch it on, and in a couple of minutes you have piping hot water ready for drinking or cooking. How exactly does the kettle work? Why does it take so long to boil? And how does it know when to switch itself off. Let's take a closer look. An electric kettle is a convenient way of making heat energy from electricity. It's a water heater, but it's also an energy conversion device that illustrates one of the most basic laws of physics, the conservation of energy. You can boil water in all kinds of ways, even in a simple pan on an open fire or stove, though an enclosed kettle is usually much faster. It stops heat escaping, allows the pressure to rise faster. Remember that water boils when its saturated vapor pressure equals atmospheric pressure and helps the water to boil more quickly. But do you ever get frustrated at how long it takes your kettle to boil? Don't you? The amazing thing is that your kettle boils as quickly as it does. Here is why. If you keep pumping heat energy into the bottom of a kettle faster than heat is escaping through the top and the sides, sooner or later the water inside it will boil. A basic law of physics called the conservation of energy tells us that if you need to boil a liter of water starting from the same temperature, you will always have to add the same amount of energy to do it. Whether you use a campfire or a kettle, a microwave, or some amazing stirring device in the manner of James Prescott Joule, the amount of energy you have to put in to boil the water is exactly the same. Let's say you start with 1 liter, roughly 1 kilogram, 2.2 IBS of cold water at about 10 degrees Celsius, that's 50 degrees Fahrenheit, and you want to raise it to 90 degrees Celsius to its boiling point, which is at least 100 degrees Celsius or 202 degrees Fahrenheit. The amount of energy you need is 4.2 times 1000 grams times 90 degrees equal to 378,000 joules or 378 kJV. The mysterious 4.2 is a constant value called the specific heat capacity of water. Every material has its different specific heat capacity, which is simply the amount of energy you have to put in to raise the temperature of 1 gram of the material by 1 degree centigrade. You need to add 4.2 joules of energy to raise the temperature of 1 gram of water by 1 degree Celsius. So water specific heat capacity is 4.2 J/G degree Celsius. 378 kJ to boil a liter of water is rather more energy than you might think. An energy efficient lamp rated at 10 watts uses 10 joules of energy every second, because 1 watt means using 1 joule per second. So it will take it 37,800 seconds, about 10.5 hours, to use as much energy as our kettle uses in a single boil. Amazing, right? If you are using an electric kettle rated at 2400 watts, that means it's consuming 2400 joules of electrical energy per second and putting roughly the same amount of energy into water as heat each second as well. Divide 378,000 by 2400 and you will find it takes the kettle about 160 seconds to do the job, which sounds about right. An electric kettle generally does take about 2 to 3 minutes to boil. An old proverb says a watch pot or kettle never boils, but that dates from the time when most people used to boil water on hideously inefficient open coal fires. An electric kettle can boil water in just a couple of minutes because it can add heat energy to the water much more quickly and efficiently than an open fire, which allows heat to escape in all directions. You should get one for yourself. For more of our content on new techs and inventions, please click on the next videos on the screen and don't forget to hit the subscribe button. Thanks for watching.